Hi guys, welcome to Mastering Project Planning YouTube channel. In today's video, we'll be discussing about the construction sequence for the concrete pipe rack foundation inside and process plant which is live. Already in the previous video, we discussed till the concrete pouring for the footing, column footing. So in this video, we will see the construction sequence after the footing concrete is poured. So once the footing concrete is poured, we'll be doing the curing works, and we also will be doing the de-shuttering works once the concrete is set. So then we may need some time for this curing works that we have to mention in the schedule. So once the footing concrete is poured, then we will start with the rebar fixing for the pedestal concrete, for the pedestal, column pedestal. So we will be checking the spacing and the diameter of the rod, and the spacing and everything is properly done as per the construction drawing. So then we will start the formwork as well. So for this rebar fixing also we may need some duration, like how many steel fixer you are going to place for this pedestal. So then accordingly the productivity is like for kg per day for the particular steel fixer. So then based on the manpower, so you will come to know the duration for this pedestal rebar fixing. Same we'll be doing it for the pedestal formwork. So that also will require based on the square meter of the formwork and how many carpenter you are going to use for that particular pedestal. Then so you will also put this duration for the formwork in the schedule. Then we may also need to place foundation bolts or anchor bolts. So that will be already it has to be already fabricated and in the workshop, and sometimes this also has to be galvanized. So that also has to be done. Galvanized is like a zinc coating on this foundation bolt. So then once this is done, then you will place this foundation bolt on the pedestal rebar, and it has to be properly anchored or tied. So we need to check the center to center distance of this anchor bolt. Sometimes we may also use templates, so where the holes will be there and the center to center distance. So this ensures that once your base plate is the column base plate is placed, so it matches correctly, so there is no alignment issues. So once this is also checked, then you also need to check what is the maximum projection length which is available. So that elevation also you need to check, because once you place the column base plate over there, then you will be placing the washer and the nuts will be tightened. So then there should be some projection length after your final nut is placed. So this everything you need to check during this before pouring the pedestal concrete. So then you will be going up with the inspection, where the QC team will come and check the whether you have used the correct bolt size and the projection lengths are correct. They also will check the rebar spacing and all the angles or the bend angles are properly done. Lap lengths they will be checking. So then they will ensure that even the formwork is also it is properly bolted, and whether it should not get loose. They will check the gap of the formwork as well. So during the concrete pouring, there should not be any leaks. So that also they check. So then they give permission for pouring the concrete. So usually we will be placing the order for the batching plant. So then this also has to be ordered. So the quantity has to be measured by the site supervisor, like how much concrete quantity we require. So then the concrete will be ordered. So the next day this pedestal concrete pouring happens, so that we need to take care in the schedule. So with the proper needed vibrators and everything, this concrete has to be properly poured for the pedestal concrete. So then so this duration everything you need to consider, like 1 day or some time may be required for the pedestal concrete. Usually you can pour this pedestal concrete in batches, like maybe you can do it for 4 for pedestal, or you can do it together for 8 pedestals. So then once this pedestal concrete is poured, so then you may need to do the curing. You may need to do the curing. Same what cube test also you need to do for this pedestal concrete. So where you need to cast the concrete for the pour the concrete in the mold for the cube mold, and this it has to be properly finished, and they will be sending this to the laboratory for doing the for testing the compressive strength of the concrete. So they do it for the 7 days and 20 days. There also they need to do the proper curing. So why we are doing is we need to check the concrete strength. So where the concrete testing machine is there, where the load is applied, so they will check like when the concrete is getting filed. So they check the load and what is the area, the cube size, the length and width. So then they check what is the Newton per meter square. So for M25, M30, there is different types of concrete grades. So for that we have this concrete strength. So this will be performed in the laboratory. We need not mention in this schedule, just I am explaining like in the field how this will be executed. So once this pedestal concrete pouring is completed, then we may need to do the curing for 7 days of then based on the procedure, like how the client has specified, or there are some specific standard that standards we need to follow. So then after 2 or 3 days, this has to be, we need to remove the shattering material. So that also we need to have some de-shattering and curing, so that you can include that particular activity. So for that maybe 7 days time for the curing works, or 10 days or 14 days, that depends on the procedure. So that you need to include in the schedule. So then we also need to do this bituminous paint application for this pedestal concrete, because you know the pedestal also will be covered with the soil up to some particular elevation. So we need to do the bituminous paint application over the pedestal concrete. So why we are doing this? So this is like the soil, if there are any moisture content left, so it should not get entry into the concrete. So if there is any like oil spills or some salt concentration, some due to rain or something, the water will be accumulated in the soil, right? So in order to avoid this moisture entry into the concrete, we are doing this bituminous paint application. Then if there is some any oil spills which happening in the later stage, then also it will protect this foundation. Then it will also reduce the corrosion if there is some salt content in the water, like some during some rains or some underground water, there is a lot of salt content is there. So then this also protects that foundation. So then it also gives you the durability of that particular concrete. So we do this bituminous paint application. So then after this bituminous paint application, so we need to start with the backfilling and compaction works. So this backfilling compaction also we need to do, like we cannot we cannot dump the whole soil and you cannot do the compaction. So we need to do the layer by layer soil compaction, like 15 centimeter, or it depends based on your procedure how you're going to compact the soil. So then once this is done, so then you may need some bobcat. Sometimes we use excavated soil for this backfilling compaction, or sometimes the soil is not suitable if the soil is contaminated. So then you need to go ahead with a different gatch material where you need to fill the soil, fill this foundation, and you need to do the compaction. So you do the layer wise soil filling by using the bobcat. Then sometimes you use the plate compactor, or they also call like a jumping jack, where they compact the soil. Then sometimes the soil also will be mixed with the water before filling. So in order to, so for your soil to get fully compacted, so you also need some kind of moisture in your soil, so that it gets compacted well. So then what they do is, like once they fill the soil like 15 centimeter or something, then they measure the field density of the soil, like we call like a field density test. So where some kind of cone apparatus, like a field cone we use. So what is that is basically is like we place a metal tray on the testing location, Then so there will be we'll be digging a hole, then we'll be collecting the soil, then we measure this, again we will be placing a cone apparatus, like where this hole will be filled with the calibrated sand. So then we measure how much soil compaction is there. So basically what we do is like we measure how much soil is getting compacted in that particular hole. So for that we need to have like a 95 percentage, you need to compaction rate you need to achieve, right? So once this is done, so we'll be filling this layer by layer compaction, and we'll be doing this test. So then once everything is done, so then we'll be having the final inspection, where the QC guys will check at the random location, then whether the what is the field density FDT. So they need to meet that 95% compaction. Hope you guys understand. You got some useful information about the pedestal concreting works for the pipe rack foundation. If you like to see more content, please like and subscribe to this channel. Thank you guys. See you in the next video.